Assalamu alaikum. Ali, can you hear me?
जी वालेकुम अस्सलाम, I can hear you.
We were doing current of electricity and we are continuing this topic. A box containing two electrical components is connected into a circuit. The variable resistor is adjusted and measurements are taken to determine the IV characteristics. The variable resistor is adjusted and measurements are taken to determine the IV characteristics for the box. Now, this looks to be a diode sketch, which arrangement of the two electrical components in the box would create the best fit to the would create the best fit to the measured IV characteristic. Now, this sketch appears to be a diode because this portion, one side is stopping the current. So this portion is reverse bias. So the other side of the sketch graph is bending towards voltage axis. It means resistance is increasing.
In parallel, the resistance will decrease, so it will be a series circuit.
It should be a series circuit, right? Now, let's move to the next question. A battery of EMF 12 volt and a negligible internal resistance is connected to three resistors, each of resistance 6 ohm as shown. What is the power dissipated in resistor R? There is no internal resistance. 12 volt is the battery. I was thinking that we should first look at the 6-6 parallel, and then we can divide it in the ratio because we do not know the current. So I think we should first find the effective resistance.
It is coming as 3 ohm.
And there is a 6 ohm resistor in series.
So 9 ohm it will become.
Now, what I can do, I have the resistance and I have the voltage. So I can find power, the total power. Now, either I should go to find the current, but I was thinking, let's go through the current route. The total resistance is 9. So I can find the total current.
It is coming as 1.33.
So we have the current and we have the resistance.
The power is coming as 16.
16.
16 watt.
But 16 is not the option.
It says dissipated in resistor R. So I think there are two resistors. So we'll take one in series and the other in parallel.
No. R is only one resistor, no? That is the 6 ohm resistor.
So 9 ohm is across this 16 watt is across 9 ohm. So we'll see how much is in 6 ohm, like the ratio then.
No. Acha, because can you repeat this calculation? 1.33 square into 6.
It's 10.6. So I think I took it at 9 as 9 before because of the word total distance was 9.
159, a metal electrical conductor has a resistance of 5.6 kilo ohm. A potential difference of 9 volt is applied across its ends. In 1 minute. So first we should find current.
The current is coming as 1.6 into 10 power minus 3.
1.6. I've taken the value of electron, the charge of an electron.
It is coming as 6 into 10 power 17.
There is a current in a resistor for an unknown time, which two quantities can be used to calculate the energy dissipated by the resistor. So there is a current in a resistor for an unknown time. So what are the possible, because he says time is unknown. So I should take the formula energy is equal to Q into V, because other formulas apart from this one all contains time.
So Q will be the charge and V will be the potential difference.
V will be the potential difference. So using this formula, which the current in the resistor and the PD across the resistor.
So C will be the answer.
C would, because the formula fit with C. This is the comparison. Now, which graph could show how the resistance of a filament lamp varies with the applied potential difference as V is increased to the normal operating PD?
So as the resistance increases, the voltage will also increase.
Actually, if this is a filament lamp, so filament lamp, the rule is there that resistance increases
Voltage decreases.
and temperature increases. So now,
So is D the answer then?
but R is increasing, R is decreasing, and V is decreasing, V is increasing. R and V cannot be inversely proportional here, because as R increases, resistance increases, voltage should also increase. C means R is constant, which is not right, because in a filament lamp, resistance increases. The important point is there, C is wrong because R is increasing. B is wrong because this graph shows resistance is 0, but resistance can't be 0. D is wrong because D says D is wrong D is wrong because D says that resistance decreasing and voltage increasing.
So even at the start, the resistance cannot be zero.
Resistance of a conductor cannot be zero. A fixed resistor of resistance 12 ohm is connected to a battery. There is a current of 0.20 ampere in the resistor. The current is now doubled. What is the new power dissipated in the resistor? But what is the present power? We can find the present power. We have the resistance and there is a current. Examiner says current is doubled. So what I was thinking, if we double the current, it will become 0.4 ampere.
It is coming as 1.92.
What could not be used as a unit of potential difference? Now, what is the unit of PD? The main formula for voltage is work upon charge, which means joule per coulomb, which means Newton meter per coulomb. Now, this is a bit tricky question because either we should work all the units or we can see what other formulas he might be using because he's showing one with voltage, sorry, one with power also. And this formula, if I work out, which formula cannot be used? A into ohm, ampere into ohm means I into R, which is correct. Watt per ampere, power upon current. That's also right. Now, this is ohm W, it means R into P power half. Now, how this formula is coming? I think it's coming from P is equal to I square R. Right? No.
What does the Newton meter stand for? The Newton meter only.
Newton, I think B is wrong because I have worked it out here. It cannot be Newton per meter. It can be Newton meter. But what about D? It is power resistance into power. How 1 upon 2? How come 1 upon 2 is coming? Is it 1 upon 2? It's a square. Because if I take I square R, that is a tricky part because surely B is wrong because Newton per meter is not possible. If you see this diagram, it's Newton into meter. That's also right. So only one is there, which is wrong. When the current in a wire is 5 ampere, the average drift velocity of the conduction electron in the wire is this. Which row gives a possible cross-sectional area and a number of conduction electrons per unit volume for the wire? Now, either I should try to solve it by trial and error because there are two unknowns, cross-sectional area and number of conduction electrons. I have the current, which is 5, but I don't have the area. I have the velocity. Now, this is the formula. Now, I think we should go for trial and error because we should try every option. We should put the area in every option and let's see which gives us the corresponding number of conduction electrons. That would be the possible solution.
A is coming as wrong. It is coming very high.
A is coming wrong.
Yes, it is coming like 1 into 10 power 10 something.
Okay.
B is also coming wrong.
अच्छा.
No, B was right. The remaining are wrong. B is giving this answer.
Now, the diagram shows the direction of the current in a metal block. The charge carriers enter the block through the phase PQRS and leave the block through the opposite phase. The number density of the charge carrier is N. Each charge carrier has charge E. The average drift speed of the charge carrier is V. Which expression gives the current in the block? So I have the formula. Now area should be, what area should I take? Should I take X into Y, which is the area?
It will be X into Y.
Hmm. So that means B is the right answer. See the working?
I also wrote it. I am getting the same as well.
Good. A metal plate of uniform thickness is connected to a cell as shown. Electron move clockwise around the circuit. Which statement about the metal plate is correct? These are actually theory questions, and electrons are coming from right to left. The average drift speed of the conduction electrons decreases as they move from right to left through the plate. But they are not moving right to, achha, they are moving right to left. Area is decreasing. If you go through the material, This is the formula. Now current should remain constant because in the series circuit,
Will the answer be A, because the number density I don't think can change of the electrons. They will remain.
number density is a constant.
So, and according to I is equal to NAVE, the area and the drift velocity are inversely proportional.
And from the equation V, this is the relation. A battery with negligible internal resistance is connected to 3 resistors as shown. All 3 resistors have the same resistance. The current in the battery is 0.30 ampere. What is the current in resistor X? They all have the same resistance. The current in the battery is 0.30 ampere. What is the current in resistor X? So if they all are of the same resistor, we can put a ratio. Because these two are, we can take any value if we want, otherwise we can take any number because they all are same. So we can find the ratio. For example, let X is equal to 2 ohm. So if this is 2, this is 2, and it will be 2 plus 2 is equal to 4. So it will be 2 is to 4, which means 1 is to 2. So you can note down here that the ratio is 1 is to 2 and the current is 0.3 ampere. In parallel, current divides in the reverse ratio of resistance. Now you can calculate this for me, and the first one will come 0.1 and the second one will come 0.2. Now, can you tell me which one will get 0.2 ampere and which one will get in parallel? Resistance and current are inversely proportional.
So we'll first find out the total like resistance in parallel.
No, just we have both the currents now. We have both the currents 0.1 ampere and 0.2 ampere.
So 0.1 will be across X.
0.1
across X.
The 0.2 will be 0.1 will be across X. No, but we are making a mistake because X is a low resistance. Na? Resistance and current are inversely proportional. So it means the current through X should be 0.2 ampere. Did you get it?
How will it be 0.2? Won't it be 0.1?
Because we have two currents, 0.1 and 0.2. Low resistance will get more current. X is a low resistance. X is only 2 ohm. So it will be 0.2 across the X because in parallel, resistance and current are inversely proportional.
So first, can we also solve this like as a parallel circuit? If we do it like it will be 1/6 and 6 ohm will be the total resistance in it.
No, just get this point. Now. There are two loops. In one line, the resistance is 2 and other line resistance is 4. So when this 0.3 will reach here, the loop, the line which has low resistance will get the more current. Now, resistance and current are inversely proportional in parallel. So you will get 0.2 ampere here and you will get 0.1 here because it's 4 ohm. So in the line of 4 ohm, you will get less current.
Okay, I got it.
So in parallel, resistance and current are inversely proportional. A cell is connected to a resistor of resistance 3 ohm. The current in the resistor is 1 ampere. A second identical resistor is added in parallel. The current becomes 1.93. What are the EMF E and internal resistance R of the cell?
In series, will it be the opposite? Like the resistance will increase the
In
current?
series, greater the resistance, greater the voltage across the resistor, current is the same. A second identical resistor, it means that would also be one that will also be now the same concept comes here. If it is 1 ampere, it will reach here because the two resistors are of the same size. So it will be 0.5 ampere and it will be 0.5 ampere.
Will it be the half of like 1.93 because it says the current increases?
Achha, sorry, it becomes 1.93. I didn't see that. You're right. So we have to do 1.93 upon 2.
0.965.
0.965. देखो 0.965 ampere is here. It is passing through each of the two resistors. Now we have the data. So we can work it out. E is equal to I R plus R. This is the first equation. How much is 1.93 into 1.5? 1.93 into 1.
895.
Sorry,
895.
So either we solve it by substitution or we can use trial and error. Both options are available because now I have two equations. One option is there that if I put R, the small r, and I get E in any equation, or I solve it simultaneously.
R is coming as 0.113.
0.113. It means you say it's A.
C option.
Acha, C option. Okay, we have done a good number of questions today, and I think we just keep it up to here, and we will do it inshallah in our next class. Okay, Allah Hafiz.
Allah Hafiz.